Welcome to the 16th video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will discuss how to multiply vectors. Multiplying scalars is pretty straightforward, but when multiplying vectors, we have two choices. The result can either be a scalar or a vector. The kind of vector multiplication when the result will be a scalar is called dot product, because we denote this multiplication by a dot. It is also called scalar product sometimes, precisely because the result is a scalar. If there is an angle phi between the vectors a and b, the dot product of the two vectors can be calculated by multiplying the length of the two vectors and multiplying that with the cosine of the angle phi between them. Let's now do a quick concept check. How does the sign of the result depend on the angle? The result is positive if the cosine of the angle is positive, so when the angle is acute. For example, the angle between the vectors u and v is less than 90 degrees, so their dot product will be positive. If the angle is 90 degrees, then the cosine is 0, so the whole dot product is 0. This means that for perpendicular vectors, such as for u and w, their dot product will be 0. Finally, if the angle is larger than 90 degrees, the result will be negative. For example, in the case of the u and z vectors. From the definition of the dot product, we can also see that it is a commutative operation. This means that u times v is the same as v times u. Let's see now the dot product of unit vectors. Remember, unit vectors have a length of 1 and they point toward the x, y, and z axes. Multiplying any unit vector with itself results in 1, because cosine 0 degrees is 1. However, taking the dot product of two different vectors, so i.j, i.k, or j.k, will be 0, because these vectors are perpendicular to each other, so we have cosine 90 degrees, which is 0. We can use all of these relations when calculating the dot product of any two vectors. To see how this works, express both vectors a and b in terms of the unit vectors. So then a vector dot b vector is ax times I plus ay times j plus az times k multiplied by bx times I plus by times j plus bz times k. Next, we have to multiply each term in the first expression with each term in the second expression. Here we have to remember that whenever we multiply two different unit vectors, the result is 0, so only the I times I, the j times j, and the k times k components will remain. Hence, the result is ax times bx plus ay times by plus az times bz. You can see that the result will indeed be a scalar because these are just simple numbers here. Let's see an example of where do we use this in physics. You might have learned that when calculating the work, only the component of the force parallel to the displacement counts. This is because, in fact, the work is the dot product of the force and the displacement. So the work is the dot product of the force vector and the displacement vector. So expressing it with the magnitude of the force and the magnitude of the displacement, there is an extra term of cosine of the angle between them. So here cosine theta, where theta was the angle between these two vectors. The other form of vector multiplication is when the result is a vector. This is called the vector product or the cross product because it is denoted by the cross symbol. The expression to calculate it is very similar to that of the dot product, but here we take the sine of the angle instead of the cosine. However, this expression here only specifies the length of the resulting vector, so you can see here are the absolute value signs. The question is, what will be its direction? To find the direction, we have to use the so-called right-hand rule. Using your right hand, point your index finger towards the first vector and your middle finger towards the second vector. Then your thumb will give the direction of the resulting vector. Try it. Stop the video and see for yourself where will B cross A point compared to A cross B. Do you have the result? You should have seen that B cross A points to the opposite direction than A cross B. This is an important result that we will use now. To calculate the cross product of any two vectors, first let's see what is the cross product of the unit vectors. If you take the cross product of any unit vector with itself, so I cross I, j cross j, or k cross k, the result will be 0. Taking the cross product of two different unit vectors gives the third one, but sometimes with a minus sign. Try to see this for yourself, using your right hand. Similarly to the case of the dot product, we can also express the cross product of two vectors with their components. The result will be this. So A cross B equals A1BZ minus AZBY times I plus AZBX minus AXBZ times J plus AXBY minus AYBX times K. This is a quite long expression, so to memorize, the so-called determinant method is sometimes used. We write the unit vectors and the vector components in this structure. Then, when calculating the multipliers of each of the unit vectors, we only take the A and B components that are not in that column. Okay, so then we only take, for the I unit vector, we only take these components, and then we multiply and subtract them in the following way. So AY times BZ minus AZ times BY. Okay, we do it in this cross fashion. AY times BZ minus AZ times BY. And this is indeed what we can see here, that this is the multiplier of I. Now let's see for the unit vector J. So then we cannot use the components in this column. So instead we have these two and these two. So what we do is AZ times BX minus AX times BZ. And that's indeed what you can see here, AZ times BX minus AX times BZ. And finally, for the K unit vector, we can only use these four components, so the result will be AX times BY minus AY times BX. And we can see that it's the same, AX times BY minus AY times BX. There are important physical examples for the cross product as well. You might not have learned about these in school yet. If so, don't worry, we are going to discuss them later in more detail. Now I just want to show you that cross products come up in many physical laws. For example, the angular momentum can be calculated as the cross product of the position vector and the momentum vector. The torque is also the cross product of the position vector and the force vector. And there is also the formula for the Lorentz force. This is the force acting on an electrically charged body in a magnetic field. So here, the Lorentz force can be expressed as Q, which is the electric charge, times V, which is the velocity of the object, cross B, which is the strength of the magnetic field. Thank you for your attention and see you in the next video.